Imagine sitting inside a tank and seeing the battlefield as if the armor around you simply wasn't there. Not through a tiny periscope, but in full 360 degrees. That is the idea behind a new generation of armored vehicles. Cameras cover the hull. Infrared sensors see through darkness. Radar searches for threats. Laser rangefinders measure targets. That information reaches the crew's helmet display. It sounds like science fiction, yet it is being demonstrated. I've never seen a tank covered with this many cameras. Then you notice the crew's augmented reality displays. The crew can stay inside the armor while the sensors do the looking. This isn't about better cameras. It is about turning the vehicle into one giant sensor. The same idea is appearing across China's newest armored vehicles, infantry fighting vehicles, reconnaissance and fire support platforms. They are being equipped with CCD cameras, infrared systems, phased array radar, laser sensors, digital communications, and helmet-mounted displays. The goal is a constantly updated battlefield picture, day or night, through smoke and difficult weather. It could feel like the armor has become transparent. Now imagine that in combat. A suspicious movement appears behind the vehicle. The system detects it and puts the location on the helmet display. The crew turns toward it without exposing themselves. That is a major change from traditional tanks. The United States once tried a related concept through future combat systems, connecting tanks, infantry, artillery, aircraft, and command units. But it was canceled. China's newer vehicles are taking that idea further. 120. Traditional tanks have one major weakness. They cannot see everything. Closed hatches protect the crew, but limit their vision. Periscopes and cameras help, yet blind spots remain. In a city, those blind spots become deadly. During the First Chechen War, Russian T-80 tanks entering Grozny faced anti-tank attacks from buildings and narrow streets. The tanks had enormous firepower. Finding the enemy was harder. There is a brutal trade-off inside an armored vehicle. Want better visibility? Open the hatch. Want protection? Keep it closed. Commanders have been hit by snipers and enemy fire because they needed to look outside. Remote weapon stations reduce that risk. But one camera cannot watch everything. One screen cannot show it. But making this system work is extremely difficult. Battlefield electronics have to survive vibration, dust, heat, cold, water, shock, and combat damage. The cameras must keep working. The sensors must communicate. The helmet must track exactly where the crew member is looking. And the information has to reach the display almost instantly. Even a small delay could make the system less useful. So the real challenge isn't simply building AR glasses. It's building an entire electronic nervous system for the vehicle. China has already been developing pieces of this technology for years. At the Zhuhai Air Show, Chinese defense companies demonstrated smart infantry helmets combining low light and infrared imagery with battlefield information on an AR display. The concept is straightforward. Take what a soldier can see, add what the sensors can detect, then put both directly into the soldier's field of view. Now scale that idea up to an armored vehicle. Suddenly, the amount of information becomes enormous. A tank has far more sensors than a soldier can carry. Multiple cameras, infrared systems, radar, lasers, radio links, navigation systems, and data coming from other units. No human can process all of that simultaneously. That is why the most important word in this new generation of vehicles may not be cameras. It may be intelligence. The vehicle needs onboard systems capable of sorting huge amounts of information and deciding what matters most. Otherwise, the crew simply gets buried under data. And there is another problem. All that information needs somewhere to go. High-resolution video requires bandwidth. Multiple sensors require even more. Then add digital radios, data links, and BeiDou satellite connectivity. Now the vehicle can potentially receive information from ground units, aircraft, command centers, and satellites. The tank is no longer operating as an isolated machine. It becomes one node inside a much larger battlefield network. Instead of simply looking through armor, the crew could receive a constantly updated picture of the battlefield.